Most commercial applications that expose services as RESTful implementations also distribute so-called value-added toolkits that describe the interfaces to developers in popular programming languages. Bandwidth is particularly important and needs to be limited. REST is particularly useful for limited profile devices such as PDS and mobile phones, for which the overhead of headers and additional layers of SOAP elements on the XML payload must be restricted. Web service delivery or aggregation into existing websites can be enabled easily with a RESTful style. Developers can use technologies such as asynchronous JavaScript with XML called AJAX and toolkits such as direct web remoting called DWR to consume the services in their web applications. Rather than starting from scratch, services can be exported with XML and consumed by HTML pages without significantly refactoring the existing website architecture. Exciting developers will be more productive because they are adding to something they are already familiar with, rather than having to start from scratch with new technology. Why use REST architecture for web services? Representational state transfer is a new architecture for web service that is having a significant impact on the industry. Most of the new public web services from the large vendors like Google, Yahoo, Amazon, Microsoft rely on REST as the technology for sharing merging information from multiple sources. REST is not an official standard, but rather an architectural style of networked systems consisting of clients and servers. Clients initiate requests to servers. Servers process requests and return appropriate responses. Requests and responses are built around transfer of representations of resources. A resource can be essentially any coherent and meaningful concept that is addressed. A representation of resource is typically a document that captures the current or intended state of a resource. The motivation behind REST web services is what drives the progress of technology to make complex things simpler. The first generation web services relied on exchanging XML packets conforming to SOAP. SOAP means Simple Object Access Protocol. Specification use HTTP protocol. In fact, web services specification does not say that SOAP messages have to be exchanged over HTTP. This is the direction that Microsoft went with their WCF architecture. This decouples SOAP messaging from the underlying communication protocol, allowing for TCP/IP and other ways of exchanging SOAP. But do we need SOAP at all? Supporters of REST architecture consider SOAP and XML to be too heavy. HTTP itself has enough capabilities for applications to communicate over the network. In reality, HTTP is what powers the web, and it has very rich vocabulary in terms of verbs, URIs, request and response headers, and internet media types. It also common in REST services to use JSON, means JavaScript object notation, as a convenient fat-free alternative to XML. JSON, being a subset of JavaScript, is an ideal data format for building poor HTML clients running in web browsers with embedded JavaScript logic and accessing REST resources in an asynchronous fashion using AJAX for highly responsive user interfaces. With the explosion of the web and now Web 2.0, it is only now that we are beginning to see automatic interaction between different websites and between websites and client application, websites and business databases as part of more global interconnection. On the web, data is moving faster than we can browse it. Hence, there is a strong demand for programmers that can find, track and monitor information coming from diverse sources, including sales data, financial information, online communities, marketing campaigns, to name the few. This diagram shows us what are the layers that these architectures and technologies belongs to. The rapidly emerging web services technology has the potential to change the way internet works for businesses. Currently, web services work well for business to consumer applications. They don't for business to business applications. For instance, an individual customer can easily purchase a book from an online vendor, but for a bookstore wanting to make a volume purchase, it is far more complicated. The bookstore potentially more need to use multiple applications to track sales, determine reorders and track shipment. Often data from one application needs to be re-entered into other applications, making the whole process inefficient. Web services should be able to address this issue. REST can also change the way how complex systems are architected. Traditional service-oriented architecture, called SOA, is slowly moving towards web-oriented architecture, WOA, the term coined by Dion Hinchcliffe, where applications leverage a rich web of REST resources. Instead of a few point SOA services, enterprise data will be exposed through millions of granular REST resources, like the web itself. REST is quickly becoming the preferred technology for building arbitrary applications that communicate over the network. REST fully leverages protocols and standards that power the World Wide Web and simpler than traditional SOAP-based web services. With the emergence of cloud computing and the growing interest for web-hosted applications, REST-based technologies can be helped both in the development of rich user interface clients calling into remote servers, and in the development of actual servers for manipulating data structures in a client application, written in any language or directly in the browser. Example for REST. Example, airline reservation service. Suppose that an airline wants to create a telephone reservation system for customers to call in and make flight reservations. The airline wants to ensure that its premium members get immediate service, its frequent flyer members get expedited service, and all others get regular service. There are two main approaches to implementing their reservation service. Approach 1. Press 1 for Premier, press 2 for. The airline provides a single telephone number. Upon entry into the system, a customer encounters an automated message. Press 1 if you are a Premier member. Press 2 if you are a frequent flyer. Press 3 for all others. Approach 2. Telephone numbers are cheap. Use them. The airline provides several telephone numbers, one number for Premier members, a different number for frequent flyers, and still another for regular customers. Discussion. In approach 1, the answering machine introduces an extra delay, which is particularly annoying to Premier members. Doesn't everyone hate those answering systems? With approach 2, there is no intermediate step. Premier members get instant pickup from a customer service representative. Others may have to wait for an operator. Web-based reservation service. Suppose now the airline wants to provide a web reservation service for customers to make flight reservations through the web, just as with the telephone service. The airline wants to ensure that its Premier members get immediate service, its frequent flyer members to get expedited service, to others get regular service. There are two main approaches to implementing the web reservation service. The approaches are analogous to the